Good morning, one and all. Myself, J. Anusha, working as lecturer in physics under the department General Section in SS Government Polytechnic, Zahirabad. And for first year, second sem students, the subject what I'm dealing with is applied physics. And the subject code of applied physics is 18 common 203F. And the main topic what we are going to discuss in today's class is our fifth chapter, that is electricity and measuring instruments from our syllabus. And from this chapter we are going to discuss what is superconductivity. Now to understand this we are using PowerPoint presentation. The main objective of our class is, on completion of our class, you'd be able to understand what is superconductivity and what are properties of superconductors and what are applications of superconductors. Now, before moving on to today's class, let us recall what we learned in yesterday's class. That is, we have studied about meter bridge. Now, what is superconductivity? Now, this property of a material superconductivity was discovered in 1911 by a Dutch physicist Kamerlingh Onnes, for which he got Nobel Prize in 1913. Now, what is the definition of superconductivity? The property of a material by which it exhibits zero resistance at less than critical temperature is called superconductivity. Know that conductivity is our conductor. What it says, it allows flow of current. When a material allows flow of current, when its resistance is very low. Now here we are calling the material as superconductor, or else the property as superconductivity. So we can say that it conducts more, nothing but its resistance is 0. Now when its resistance is 0 at critical temperature, or when the temperature is less than critical temperature. Now here we can understand this property by considering an example of a material called as mercury. When it is cooled below 4.2 Kelvin, it shows zero resistance. What it means? When the temperature is less than 4.2 Kelvin, the resistance of mercury is becoming 0. So we can say that 4.2 Kelvin is critical temperature of mercury. And we can say that this is the property of mercury, which is known as superconductivity of mercury, because its resistance is becoming 0. Now what is critical temperature? The temperature at which the electrical resistance of material becomes 0 is called critical temperature. When the electrical resistance of a material becomes 0, we can say that the temperature is critical temperature. Now what are superconductors? The materials which exhibit 0 electrical resistance below certain temperature are called superconductors. Now here we can see a tabular form which is showing us different materials like gallium, aluminum, indium, tin, mercury, lead, niobium, and we can see different oxide materials. For every material we are having a particular temperature which is known as critical temperature. We can say that for tin it is 3.7 Kelvin. It means below 3.7 Kelvin tin resistance become 0. So these are examples of superconductors. Now let us see what are properties of superconductors. The first property is the resistivity of the superconductor is 0 at less than critical temperature. There will be no joule heat when current passes through the superconductor. Now, as long as the current passes through the superconductor, the material will not produce any heat. Next property is known as Meissner effect. Now, what is Meissner effect? It is inside the superconductor, magnetic field is 0. So, for superconductors, inside the superconductor, magnetic field is 0. Next property of superconductor is it shows perfect diamagnetism in the superconducting state. The critical temperature is inversely proportional to isotopic mass of the material. Next, thermal conductivity is low in the superconducting state. A strong magnetic field and electric field and high temperature can be destroying the superconducting state. Now, when a material kept in a very strong magnetic field or very strong electric field and or at high temperature, they can destroy the superconducting state of the material. At room temperature, superconducting materials have greater resistivity than other elements. At room temperature, superconductive materials have greater resistivity than other materials. Next property is telling about persistence of current. Current once set up in superconductor continuously flows for very long time. So for very long time we can make a superconductor to behave or else to store current in that material. What are applications of superconductors? Now we can use superconductors in the production of magnetic levitation trains. We can call these trains as bullet trains. As we all know that bullet trains are the fastest trains. So in the production of these bullet trains or magnetic levitation trains, we can use superconductors. Next, in MRI scanning, magnetic resonance imaging, we can use superconductors. And we can use superconductors in switching devices. And we can use superconductors in superfast computers. And we can use superconductors to transfer electric power from one place to another place without any resistive losses. To produce high intense magnetic field, we can use superconductors. And here we can see a particle oscillator which is known as Hadron Collider. In Hadron Collider, we can use superconductors. In the production of sensitive magnetometers based on superconducting quantum interference devices. We call these devices as QUITs. By using these devices, we can produce sensitive magnetometers. So what we have studied or what we discussed, let us summarize. We have seen about superconductivity and what are properties of superconductors and what are applications of superconductors. First of all, what is superconductivity? It is property of the material which shows zero resistance at below critical temperature. Now this is the property of the material, and the material which exhibits this property is known as superconductors. So for superconductors, electrical resistance is zero at a particular temperature. Now these substances have different properties. Now because of the importance of these properties, these superconductors are used in many areas, so that we have seen in applications of superconductors. Now let us see how much we have understood from the from listening this class. So what is superconductivity? Who observed superconductivity? Superconductivity was first observed by Ohm, Ampere, Camerlingons or Schiffer. So as we have seen in the introduction of superconductivity, it was observed by Camerlingons. Next question. In superconductivity, the electrical resistivity of a material become, is it 0, finite, infinite, none of the above? So we have seen this in the definition of superconductivity, that its resistance, electrical resistance is 0. Now superconductivity is exhibited by hydrogen at 4.2 Kelvin, mercury at 4.0 Kelvin, mercury at 4.2 or potassium at 4.2. It is mercury at 4.2 Kelvin. This is what we have seen in the example of superconductivity. The superconducting state is perfectly diamagnetic, paramagnetic. We got both paramagnetic or ferromagnetic. So both B and C are same, and the answer for this question is also the same, that is paramagnetic. What are superconductors used for? Is it for toasters, washing machine, magnetic resonance imaging or water parks? So this is what we have seen in applications of superconductors, that is superconductors are used in magnetic resonance imaging. The ideal superconductors exhibits Meissner effect, mesmeric effect, mesomeric effect, monomeric effect. This is what we have seen in properties of superconductors, that is they exhibit Meissner effect. So this is what we have seen in today's class. So what are frequently asked questions from this topic? So you may get questions like what are superconductors with the example, and what are properties of superconductors, and what are applications of superconductors. This is very simple and very important topic in the chapter, that is superconductivity, because nowadays we are like the every work what we do, that must happen in a quick time. So we can see the flow of current is more in these substances because its resistance is 0. So there is no opposition for the flow of current. So these materials are very much important in different applications in our aspects. So with this we are concluding today's topic, that is superconductivity. Thank you so much. Hope you understood what is superconductivity.